Why it doesn't work? Let me check. Okay, it is working now. So let me solve a problem, which is a Facebook hacker rank round 2. The first problem. This problem is not very difficult, but it is also not very straightforward to solve. Okay, so since I can only share my screen using IntelliJ, so I will put the question in the IntelliJ. So the problem is you can go to this address to see the problem. So the problem is a little bit takes some time to understand it. Okay, so the problem is there are several models who wear suit or wear clothes which is a certain color. Okay, and then the model need to change suit to fit for the question requirement. Okay, so please read the question. It takes some time to really understand the question. Okay, so let me take the question. Let me take the one example. For example, this is the number of test cases. There are 5 test cases. The first test case is has 3 rounds. Okay, and it have one model, one actor. So you can see. So the data for the first test case is as this. Okay, this is the number of rounds of this play. This is the number of actor. This number indicate what kind of situation in the initial stage for all the actor, because there are only one actor. So the initial stage for the actor is 1. Okay, is 1. This problem, 1 indicate a specific clothes the actor are wearing in the initial stage. Okay, and then there are 3 rounds. Okay, in the 3 rounds, it indicate in the specific round what kind of suit the counter actor need to run, because there are a lot of actors. So it will indicate I need to see the kinds of suits the actor need to wear. Okay, there is no sequential restriction in the list of suits the actor are wearing. There is no sequential requirement. It can be arbitrary order. So for example, in this first example, since there are only one actor, and the initial clothes the actor are wearing is 1. Okay, and then in the first round, the question requires this actor to wear clothes 2. In the second round, it requires the actor to wear clothes 2. In the third round, it requires the actor to wear clothes 1. Okay, so the question is the minimum of changes required to have this kind of workflow for all the actors, the minimum changes. Okay, So actually there are additional constraints which make the question a little bit hard. But currently, if we, without this constraint, we can see it need two change of clothes to make it work. Okay, it need two change of clothes to make it work. But in the question, there are additional requirement about this question. This makes it a little bit difficult. Is actually every actor allowed to wear two clothes in the beginning stage. So in the initial stage, the actor can wear two suits in the beginning stage. Okay. So one suit outside, on the outside, it will be in the initial stage. Okay. For example, in the current case, this one actor can wear clothes one on the outside because this need to satisfy the initial requirement. Okay, and then if this actor wear clothes two underneath, okay, then in the current station, because this actor have wear close to underneath, in the current case, this will this will reduce the number of changes for the actor. Okay, for example, in this situation, the actor, in the initial stage, it's okay, and then in the first round, because this requires this actor to wear clothes too. Okay, how to let the actor wear clothes too? In the current situation, this actor just take off the clothes one, and then clothes two is follow the requirement. Okay, so in this situation, the actor do not change clothes. Okay, so as the requirement of this problem. Okay, and then the second round, the actor also do not need to change clothes. And then the third round, because the third round need to require the actor to wear clothes one. Okay, in the current station, the clothes, as to the requirement of the problem, the actor must change clothes from clothes two to clothes one. So using this additional requirement, the number of changes of clothes for the actor is 1. Okay, so this is the first example. The second example is, so we can see, so there are 4 rounds and 2 actors. Okay, the initial condition is one of actor wear clothes 1, one of actor wear clothes 11, and the first round, second round, third round, fourth round should be this. Okay, so in the current station, actually in each round, what kind of clothes the actor need to wear, so there is no sequential restriction. So that means the order of these clothes can be any order. Yeah, you just need to see. Yeah, in the current round, I need to see this number of layout. So for example, I want to see 11 clothes, I want to see 1 clothes. I do not care which actor wear which clothes. It is do not care. So there is no sequential requirement. Okay, so in the current station, we can see that initial condition is like this. Then the following round is like the initial condition. So in this case, the actor do not change any clothes. It can follow the requirement. Okay, even actually the actor do not use this requirement to wear clothes underneath. There is no such requirement needed because it is not needed this. Okay, so this is the problem. Okay, so to analyze this problem, so actually with this constraint, where close underneath make this problem a little bit harder. The reason make it harder is because we need to consider which actor have opportunity to wear clothes underneath, which actor will use this underneath clothes in a certain situation. Okay, so we need to remember this information. Okay, how to remember this information? So in the current question, it takes some time. Please spend some time to understand the question, because this question takes some time to understand it. Okay, so let me illustrate my way of solving this problem. Okay, my way of solving this problem is actually in each round it do not care the order of the clothes. It only care I need to see this number of clothes, what kind of clothes I want to see, the number of clothes for each kind of clothes. Okay, so my way of solving this problem is do the actual simulation. Okay, so the actor begin with an initial stage, and then it will initial stage, and then go to the first round 1, and then round 2, and then until to the last round. Okay, so every stage have a certain requirement. Yeah, okay, so that I need to see this number of layout of clothes for actor. Okay, so in this stage already indicated that, yeah, and then the actor have the opportunity to wear clothes underneath the kind of outside clothes to make sure actually this kind of strategy minimize the number of changes required in this problem. Okay, so to solve this problem, so to transform from one stage to another stage, it is not difficult to, yeah, for example, one question is how many changes is needed from one stage to another stage? How many changes needed? This is one question. So if the actor cannot wear clothes underneath, how many minimum changes is needed from one stage to another stage? This is one question. Another question is if the actor have the opportunity to wear clothes underneath, how to actually implement the algorithm to make it correct. Okay, actually it is not straightforward to solve this problem. I need to remember whether a certain actor has already used this opportunity of underneath clothes and which actor has not used. Okay, so in the current problem, my way of solving this problem is as follows. So I will not coding, do live coding. I will follow using my code to understand my implementation. Okay, so let me remove this unneeded code. So this is input, and then yeah, there are some boilerplate code to read the input. I read the initial stage, and then for every round I read the round situation required, and then I will so currently the two questions I asked is what is so because there are several rounds. Okay, and then in the first round, the initial stage is initial. Yet it need to reach this round. From this stage to the next stage, how many minimum changes is really needed? I will add this change. Okay? But the difficult problem is every actor has one opportunity to wear clothes underneath, so that this kind of requirement should be utilized. Okay. So how to utilize this opportunity? I will remember using this hash map. So let me change the name to actor who having underneath clothes. Okay, actor have underneath clothes. So actually, in this case, I do not need to remember which actor have this opportunity to use underneath clothes. I only need to know. Yeah, because actor begin with an initial stage. Okay. I will use the initial stage key to corresponding to one actor. So I will get the initial value and then remember that for each initial close number, how many actors wearing this kind of clothes have the opportunity to wear clothes underneath. Okay. And then I will implement this diff operation. So when I implement this diff operation, because I need to know the minimum changes is required from one stage to another stage. This is a beginning stage, this is next stage. So I will, it can easily implement using linear time. So I will use a hash map to get the number of occurrence for each clause in the specific stage. Okay, this is also. So once I know the number of occurrence for each clause, I need to calculate the number of changes. The minimum changes is required. Okay, then I will iterate the target stage. Okay, for the target stage, because it need to be transformed into this target stage, and then for target stage, for every key, for this clause, you need to have this number of occurrence. Okay, I need this requirement. Okay, how to reach this stage? There are two strategies. One is if previous stage already have some occurrence of this clause, I can use this previous stage occurrence without change. Okay, so for example, in the previous stage, it already have some occurrence of this key. I get the occurrence of this key. If the previous occurrence is smaller than the current required occurrence, I will calculate the additional time it is needed. Okay, so this map record additional change required. So this means I need to make some change to make this requirement work. Okay, if there is no change to make this requirement satisfied, it is requires some change. Okay, and then this map record which is inherited from the last stage in get from previous stage. So this I get this number of clothes from the previous stage. Okay, if this value is bigger or than equal, okay, in this stage I get this number occurrence from the previous stage. Okay, and then if this key do not exist in the previous stage, then all this happening needed from the changes of clauses. Okay, so I know the number of I need to for example, if there are some record in this map, that means I need some changes to make this happen. Okay, but because the actor has the opportunity to wear clothes underneath, so it need to consider that scenario. So in this case, I will first do this calculation. Okay, so I can see here, I do this kind of calculation. Okay, this calculation is actor. So when we from one stage to another stage, some actor do not need to change anything. It will automatically move to the next stage. Okay, some actor do not need to change anything. It automatically get from previous stage. Let me change this name. So this is a actor without change. So actor without any change, and then this is actor left. So the actor left. Yeah, if we exclude this actor without any change, the actor left will be in this map. Okay, so the actor left need to do change to follow this requirement. Okay, this is needed. Okay, and then I can calculate easily. Yeah, to calculate the actor left. Okay, so for example, I iterate the previous stage and let's get the occurrence of each key. Yeah, if this occurrence happened in this actor without change, I will exclude that, and in this case I get the number of actor left except the actor without any change. Okay, so the actor left need to change clothes to follow the requirement of changes required. Okay, changes required. Okay, and then so the actor left need to make change clothes to follow the requirement of action required. Okay, so I iterated the actor left for every close. This current wear. Yeah, for this close. Yeah, how many times it wear. Okay. So for this kind of actor, I iterate every actor. Okay. And then because it need to change for this actor left, they must change clothes to follow the requirement. They must make change to follow the requirement. Okay, but they can utilize one clothes underneath to reduce the number of changes. Okay, so in the current case, I will say that if the current actor wearing these clothes have opportunity to use the underneath clothes, then I will reduce this occurrence. If this equals 0, that means I remove. Okay, for all the clothes the actor initially wear, there is no such opportunity to wear underneath clothes. Okay, so if there are opportunity to wear the underneath clothes, I will make this opportunity and do not increase the number of changes. Okay, if for this actor I use the clothes number to distinguish the actor. Okay, so for this actor, if it do not have opportunity to wear underneath clothes because one opportunity is already used, in this case this result will be incremented. Okay, using this strategy, it will solve this problem. Okay, the most difficult part of this problem is to bookkeeping. Which actor have opportunity to use this underneath clothes to minimize the number of change of clothes? Let me run this input to get the output. Okay. Actually, the time complexity of this algorithm is a linear time. Actually, it is not linear. It is a round number and actor number. Okay, so it is a round number multiply actor number. Okay, so this is an actual solution for the Facebook hacker rank round 2, the first question. Okay, thanks a lot. This is my first recording. In the future, I will do more recording about algorithm problem solving. Thanks a lot.